Calculating Q, aka calculating energy gained or lost. In the previous lecture, we introduced this concept of energy being the ability to do work. In this lecture, we're going to go over how to measure energy and the different types of energy. Energy is measured using one or two different units. The first unit is joules. This is typically used in physics or chemistry to measure energy. This will be the most common unit that we use in this class. Calories are the units to measure energy for food. We also use calories to measure other items. Now, when I say calories, there are two versions of the unit calorie. Calorie with a lowercase c and calorie with an uppercase c. We differentiate these two units by calling calorie with an uppercase c by the word kilocalories. The following are the conversion factors for these units. 1 calorie is equal to 4.184 joules. 1 kilocalorie is equal to 1,000 calories. During the previous lecture, we went over when energy is gained by a system or when energy is lost by a system. To determine if energy has been gained or lost, it's important to calculate how much energy change there was in the system. So a bit of review. If a system is endothermic, this means that it has gained energy. We represent this by writing the amount of energy with a positive number. Words that hint at an endothermic system are things like add, absorb, or gain. If a system is exothermic, that means that it has lost energy or is losing energy. We represent this by writing the amount as a negative number. Words that hint at an exothermic system are lose, release, or evolve. For each of the following, please write the energy amount changed as either a positive or a negative number based on whether the system is endothermic or exothermic. Bread baking in an oven absorbs 346 calories of energy. Absorbs. Positive 346. A cup of coffee sits out too long and loses 4,300 joules of energy. Loses. Therefore, we write negative 4,300 joules. Finally, Olivia uses her freezer to cool off a hot piece of pork, and it releases 540 calories of energy. Releases. Therefore, we write negative 540 calories. In this lesson, you will be required to learn how to convert between the three different energy units that we've just gone over. To do this, you will use the regular rules that you have understood and learned through our previous unit of dimensional analysis. For example, if a car uses 430.5 joules of energy to move, how many calories of energy is this? Where 4.184 joules is equal to 1 calorie. Well, you write down what you're given, and the word uses establishes that the car has lost this amount of energy. Therefore, we are writing a negative in front of the 430.5 joules. Next, we are going to set up our parentheses, and we are going to situate the two terms inside of our conversion factor so that joules cancel out and we're left with calories. The 1 is on top, so we're dividing negative 430.5 by 4.184. This gives us negative 102.89 calories. Rounded, because the given measurement has 4 significant figures, our actual answer is negative 102.9 calories. In another example, if Jesse uses 4.34 kilocalories of energy to heat a pot of water, how many calories is this? Where 1 kilocalorie, is equal to 1,000 calories. We write our given 4.34 kilocalories and we set up the parentheses. We set up the units so that kilocalorie cancels out and we're left with calories. The 1 is on the bottom, so we multiply across, and our answer is 4,340. This number has 3 significant figures. Now, calculating the amount of energy. There's a specific equation that's involved when we're trying to figure out if energy was gained or lost by a system, and that is Q equals mc times change of T. In this equation, Q is the amount of heat energy gained or lost. In this equation, m is the mass of the object we are studying. C represents the specific heat of the object. And triangle T is the change in temperature of the object we are studying. A bit more about Q. Q stands for the amount of heat energy absorbed or lost by a system. Q will almost always be measured in joules. These will be the units that you present Q in. Q can be positive or negative based on how the question is worded. Words like absorb, gain, or add mean that Q will be positive. Words like lose, release, or expel mean that Q will be negative. Now, some more information about M. M represents the mass of the object. Remember, the unit for mass is always grams. If a mass is given in kilograms, you must convert it to grams before proceeding by multiplying it by 1,000. Mass must always be positive. More information about C. C represents specific heat. Now, specific heat is the amount of energy needed to raise the temperature of 1 gram of an item by 1 degree Celsius. The unit for specific heat is joules per gram degree Celsius. Written as follows: capital J divided or slash lowercase g and degrees C. The units are meant to cancel out with the other units in the equation, to leave only the desired unit behind. More information about triangle T. Triangle is a symbol in science that stands for change in. Change T means change in temperature. To find the change in temperature, you subtract the original temperature from the final temperature. Therefore, your final temperature minus your initial temperature equals your change in temperature. The unit for temperature is degrees Celsius, which is represented by degrees C. Here is your first practice problem. Lenny is working with 34.5 grams of water. If he heats the water from 20.4 degrees Celsius to 32.6 degrees Celsius, how much energy does the water gain? The specific heat of water is 4.184 joules over grams degrees Celsius. It is often simpler to identify what variables we have so that it's clearer to see which variable we don't have. So the first thing that I want you to do is write out the 4 variables that we're looking for: Q, M, C, and change of T. Next, we read the question again and we write down what quantity corresponds to which variable. Lenny is working with 34.5 grams of water. Therefore, this is the mass, or M. We write 34.5 G, or grams, right by M. If he heats the water from 20.4 degrees Celsius to 32.6 degrees Celsius, these are the 2 temperatures that we need. Our final temperature is 32.6 degrees Celsius, and our initial temperature is 20.4 degrees Celsius. Therefore, the difference between the final and the beginning temperature is 12.2 degrees Celsius. We also know that the specific heat of water is 4.184 joules divided by grams degrees Celsius. So this will be aligned with C. Therefore, what we're missing and what we need to calculate is Q. Okay, so we are going to use our formula Q equals MC change of T to figure out Q. We simply multiply everything together. So we have 34.5 grams times 4.184 J divided by G degrees Celsius times 12.2 degrees Celsius. Notice that the units cancel out. The grams are in the numerator and the denominator. The degrees Celsius are in the denominator and the numerator, and the only thing we've got left is joules. And then also, remember that we are looking at our original problem, and we're giving the least amount of significant figures. So because all of our original measurements had 3 significant figures, we're going to have to round to 3 significant figures. Practice problem 2. Kiana is trying to determine the specific heat of a piece of metal. She places it in the freezer and the metal released 430 joules of energy, and it cools from 18.6 degrees Celsius to 1.2 degrees Celsius. She knows the metal's mass is 43.5 grams. What is its specific heat? Again, we're going to write down the variables that we need to find. This makes it clearer to see which variable is missing. And now we're going to read the problem again and try to align each corresponding quantity to its variable. Kiana is trying to determine the specific heat of a piece of metal. Therefore, we're going to have to solve for C, specific heat. So we put a question mark by the C. She places it in the freezer and the metal released 430 joules of energy. Q is going to be negative 430 joules. We're also given the temperature. The beginning temperature is 18.6 degrees Celsius, and the final temperature is 1.2 degrees Celsius, giving us an overall temperature change of negative 17.4 degrees Celsius. Finally, the metal's mass is 43.5 grams. We put that next to lowercase m. This time, we're going to substitute in everything that we know, and we're going to leave C as it is. We're not going to multiply across this time, because we want to leave C by itself. What we are going to do is we're going to multiply the 43.5 grams by negative 17.4 degrees Celsius. And then we are going to divide both sides by the product, which is negative 756.9 grams degrees Celsius. This will give us our specific heat. And we have to round it to 2 degrees or 2 significant figures because of the 1.2 and the 430.